Nerdettes, let's go. Okay, so I'm going to kind of talk you through the 5 different sections in case you're having a little bit of trouble. Okay, so right now all we have here is H2O. H2O. Okay, and our directions, we're going to only do this 3 times, but what we're going to do is we're going to split. Okay, when we split our water, we have a hydroxide, and then we also have a hydrogen. The hydrogen won't stay by itself because it's not stable. It's just basically one proton, so it's going to connect on to a water over here. Woo! Okay, and now we have 3 hydrogens with our 1 oxygen, so it makes H3O. Okay, these are the 2 things that we're always counting to see if we're more acidic or basic. Okay, so right now on here, what you can see out of mine, H3Os I have 1, and OHs I only have 1. That's what I'm always comparing. So this is why this is a neutral substance. This is neutral because my number of OHs and H3Os are equal. Okay, and we're writing these as fractions and we're putting it over water. So on here, what you guys can see, 1, 2, 3, 4. 1/4, 1/4. It's a neutral substance because we have the same amount of hydroniums as we do hydroxides. Okay, so let's go back and let's look at scenario 2. Now with scenario 2, we're going to keep all of our waters, okay, and you just play around with your numbers. Ours is going to be a little bit different, but now we're going to add hydrochloric acid. Okay, so now we're going to add, we'll put an HCl up there, we'll place another one down here, and we'll place a 3rd one over here. I want you guys to do your numbers, so you should have 10 waters, and you should also have, looks like you should have 5 hydrochloric acids. Okay, so this is our new solution. Our new solution is now water molecules, okay, but we also have hydrochloric acid, HCl. And now what's going to happen is the hydrochloric acid is going to split up. Okay, when it splits up, we make another hydronium. Chlorine is left by itself. It's negative Cl. We split up HCl. Chlorine stays by itself. HCl splits up. Chlorine stays by itself. And there we go. Okay, we're always counting the same things. Okay, so right now, with what I've done, I now have 1, 2, 3. Okay, use your numbers. What do you get when you divide up all 5 of your hydrochloric acids? What's your final fraction for your number of hydroniums? Okay, I currently have 3. And right now I don't have any hydroxide. There's no OH by itself. This is still H2O. Okay, so over here I have 0. I still write it as a fraction. I'm going to place this over the amount of waters I have. So 1, 2, looks like I only have 2 waters left. Okay, so now looking at this substance, this I have a lot more H3Os, a lot more hydrogens. Okay, that's what makes this an acid. This is now an acid substance because there's a lot more hydroniums than I have hydroxides. In fact, I don't have any hydroxides. There are none by itself. Okay, that's the second scenario. That's the questions you're answering. All right, let's take a look at section 3. We're going to get rid of our hydrochloric acids. We're going to go back to just waters. Every single time, start out with 10 waters. Okay, I'm starting out with 1, 2, 3, 4, 5, 6. Okay. All right, so now we're going to be adding some, what are we adding? Now we're adding NH3. Okay, that's the white cards. So I'm going to place 1 there. NH3, NH3. Okay, so now what's going to happen is, if we read through the directions, you should have 10 waters and 5 ammonias, 5 NH3s. Okay, our water is going to split apart. The reason for this is right here we have 2 electrons by NH3, and it's more electronegative. It's going to steal this hydrogen away. There's more pull. Okay, and now we make NH4, which is still ammonia. Okay, we're going to do this over here, and we're also going to do this over here. Okay, so now if we take a look, we're going to count up our H3Os. That's what determines if something is an acid. And right now, we don't have any H3Os. Okay, so there are 0. Now we're going to count up our OHs, which we have 1, 2, 3. Go ahead. With your 10 waters and your 5 ammoniums, count up how many OHs you have. All right, and then we place them both over our number of waters. So in mine, it looks like we have 1, 2, 3, yep, just 3 waters. Okay, so now for this substance, 0 out of 3, 3 over 3. Okay, we have a lot more hydroxides. That's what makes something basic. This is a base. And it's simply because we have more hydroxides. Okay, more hydroxides than hydroniums. All right. Fourth one. Always go back to water. Okay, so I'm going to get rid of all my ammoniums. Go ahead and make 10 waters again. Pause if you need to. Okay, now I have all my waters, and now we're adding NaOH. Okay, so now we're going to add sodium hydroxide. Sodium hydroxide. Sodium hydroxide. And we'll have another one here, sodium hydroxide. Okay, so once again, we know that sodium hydroxide is an ionic compound. Sodium has a charge of +1. Hydroxide, OH, has a charge of -1. Okay, we also know that water is a polar molecule. Okay, remember that more of the electrons are on this end around oxygen, and hydrogens are slightly positive. For this reason, this guy reacts. Okay, so what ends up happening is this guy splits, and sodium just kind of hangs out around over this oxygen. It's not connected, it's just making very weak bonds. It kind of pulls it away, and we're left with a hydroxide by itself. Okay, so we're going to do this 3 times. We're going to just separate that, and we're also going to separate this last one, if you guys can see it. Okay, so now water, 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 water. Okay, so we still have 1, 2, 3, 4, 5. We have 6 waters still. So that's our bottom fraction. And now H3Os, we have none. There are no H3Os. Okay, so 0 out of 6. And now we have 1, 2, 3. There are 3 OHs that are left by themselves. Okay. There are more OHs than there are hydroniums, making it a basic molecule. Okay, let's do our last one. Group. 1, 2, 3, 4, 5, 6. All right, start off with your 10 waters. Okay, and now in this last one, we're going to add 2 things at once. We're going to add a hydrochloric acid, but we're also going to add, what else are we adding? Just make sure I'm right. Yep, we're going to add hydrochloric acid, and we're also going to add sodium hydroxide. So we're going to be adding 2 things at once. Okay, so we're going to take some HCl's. HCl. I'm only going to do 2 of each because it's a little crowded. HCl, sodium hydroxide, and sodium hydroxide. Okay, so currently what we're doing is we have water in our solution, and now we've also added an acid into our solution and also a base into our solution. Anytime that we're mixing an acid with a base, the acids and bases will interact. We're going to do a double replacement. Okay, so once again, hydrogen slightly positive, chlorine is slightly negative, sodium slightly positive, hydroxide is slightly negative. Okay, so we're going to just switch partners. What ends up happening is this. Okay, and what we then get is this is a water. Okay, and now this is salt. This is NaOH. Okay, so we're going to do that 2 more times, or actually just 1 more time. So we're going to switch our partners. So we're going to make sodium chloride and then another water. Okay, so for this last one, for mixing an acid and a base, what ends up happening, we don't have any hydroxides at all. Okay, and there are also no OHs. 0, 0. Okay, we do have salt, but that's not going to be acidic or basic. The only thing you ever count for acid and bases is hydroniums and OHs. And now we count 1, 2, 3, 4, 5, 6, 7, 8. Now we're out of 8 because we actually have more water that we've created. Okay, fractions are the same, they're equal, so now we are neutral. Okay, make sure that all your sentences on your page are full sentences. So you have to go back. If you just wrote down, for example, like number 2, if you wrote down if you wrote down the word base, change that to say NaOH is a basic substance. That's what I want you to do. So full sentences for all of these. What is your evidence for your conclusion? For evidence, you have to have numbers in here. Anytime they're looking for evidence, give me what your fractions are, tell me which one is more, and why it's either an acid or a base. Okay? And we should be all set with our lab.